So let's start first. Okay, so we will be covering these 24 DSA patterns, right, in 24 days. So today we will be covering this 2 pointers, the next day fast and slow pointers, and so on. We will cover all these patterns and we will be solving the problems for each pattern, right? And yes, I will be giving you the sample questions so that you can practice. So let's start. Okay, so what is 2 pointers? So basically it's a technique that involves 2 pointers or indices, we can say, to iterate over a data structure, usually an array or a string, to solve a problem, right? Let's say if we are having one array, right, 1 2 3 4, okay, 1 2 3 4 5, right? So we will be having 2 pointers. One can be here, one can be at the end, right, or both at the same point, right? One will be moving slow and one will be moving faster, right? So basically we will be having the 2 pointers. This is the approach. We will be having 2 pointers. And when to use 2 pointers? Basically when we need to find the pairs, the triplets, or the subarrays meeting the certain conditions, at that point we will be using the 2 pointers, right? So data can be either sorted or not sorted. It will depend upon the type of question, right? So basically it will decrease our time complexity. If we solve the question using brute force, it may take O n raised to power 2 time complexity, right? But using 2 pointers we can reduce it to O n time complexity. We will see in the questions. And how it works, as I said, we will be having 2 pointers, so we will be maintaining 2 pointers that will move through the data structure according to the certain rules. So there will be different rules. As I said, one pointer can be at the first position and other can be at the last position, right? And that's what I have written, one at the beginning and the other at the end. This is basically the common approach for the 2 pointers, right? And we can solve the problems like finding pairs with a sum. We will see this problem, right? And both pointers started at the beginning with one moving faster than the other, right? This is basically useful for the sliding window problems, right? Now you can say this is the other pattern, right? But in that also we will be using 2 pointers. Other will be move pointers toward each other or forward depending on the problem condition, right? So we will be solving the question with that. You will be having the more clarity, right? So typical approach, what can be the typical approach? See, initialize 2 pointers left and right. We will check the conditions based on the current pointers. We will see the question and check the condition. What is the condition, what we need to find, right? Then we will move the pointers accordingly. If condition not met, we will move left or right pointer, right? Let's say if we need to find the sum, let's say 1 2 3 4 5. I will solve this question, but as a reference I am showing you. We are having 2 pointers, one at the beginning, one at the end, and we will check the condition. Let's say we have to find the sum k, which is, let's say, 2 3 5. Okay, now we will be having 2 pointers left and right. Now condition is sum should be equal to 5. Now we will check the condition. It's 6 now, right? 1 plus 5 is 6. Condition is not met, right? We will move our left or right pointers to satisfy the condition. Now we need a smaller number, right? We need 5, but our current sum is 6, so we will move the pointers. Which pointer we will move? We will move the right pointer. Why? Because the array is sorted and we need a smaller sum, so we will reduce the number. That is, from 5 we will go to 4, right? So now we will get the sum 5. That's it. Now the second, if condition met, we will record the answer or move the pointers to find more solutions. In this case we need only one solution that we got, right? And then repeat until pointers go cross or reach the end. Let's say we need to find the sum 21. Okay, in this array, is it possible? No, it is not possible. We will move the left pointer to get the maximum sum, right? It will get 7 now. Again we will move to 3. Now what is the sum for this? It's 8, right? Now also it's not a 21. We will move again the left pointer. It's 4 and 8. 5. It's 9, right? Now also it's not met. So we will cross the pointers. At this point we will say it's not possible. We will return -1 or null. Correct. So this is the logic of 2 pointers. Basically we will be having 2 pointers, right? The first, that is the left, and the right. Sometimes we will be using one variable only, that is in this case we will be using I and j, and sometimes we will be using only I, that is we will simply we will be using for loop. In that we will increasing the I, and from the end we will be decreasing it. I will show you example from these questions. So these 4 questions we will solve today, right? And after that I will be sharing you the questions, the list of questions you may try for your practice, right? So to sum, let's see the question. So the question is to sum array input array sorted, right? So basically we are given one indexed array of integers numbers that is already sorted in non-descending order, that is ascending order, sorry, non-decreasing order, that is ascending order, right? Now we need to find the 2 numbers such that they add up to a specific target number. Okay, let these 2 numbers is number index 1 and index 2, where 1 basically the indexes should be within the bound, right? The length of the array, it should be greater than 1 or equal to 1, and should be less than the length of the array. So we need to return the indices of the 2 numbers, index 1, index 2, which okay, so added by 1 as an integer, index 1, index 2 of length 2. Okay, so basically we need to return the int array with their indexes, right? So let's see the example, and we should only use the constant space, right? The question is the example is this one. Okay, let's solve it. Okay, so this is the input. We are having 2, 7, 11 and 15. Our target is 9. Let's say k is the target and it's 9. Now what are the indexes? It's 2 and 7, right? For 2 it's 1, it's not 0, it's 1 based, right? In the question itself they have given 1 indexed array, right? So another is 2, so we need to return these indices, that is 1 and 2, right? So how can we do? As I said, we will use 2 pointers, right? So we will be having 1 pointer at the beginning here, let's say this is I, and 1 pointer at the end, this is j, right? So we will add them. What is the answer we are getting? We are getting 17, right? 2 plus 15 is 17. Now this is greater than our target. We need a smaller number, right? We need a smaller number. What we will do? We will move our right pointer, right? This is sorted, we know, and we will get the smaller number if we move this pointer towards the beginning, right? So now j will come at this point. Now what is the sum? Sum is 13, right? Now also it's greater than the target. Now also we need a smaller number. Again we will move. Now j will come at this point. What is the sum now? It's 2 plus 7. We got the result, that is 9, that is equal to the target. Now these are the indices. We will return I and j. Simple, right? If we take some another example, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we need a sum, let's say what, 3 and 8, right? What is the sum? 3 plus 8 is 11, right? We need 11. Now we will start from the beginning and the end, right? What is the sum? 1 plus 9, it's 10. We need a greater number. What we will move? We will move our left pointer, right? Array is sorted. We know we will get the larger number if we move from the beginning towards the end, right? So I will come to 2. Now what is the sum? It's 2 plus 9. We got the 11, right? So we will return these indices. Now if we need more result, we can also return 3 and 8, but in the question it's mentioned we need to return the indices of only two numbers, right? So yeah, that's it. We will return 2 and 9, correct? Okay, so let's code it. How to code it here only. Okay, so at the beginning we will be having 2 pointers, right? That is int left, that will be initially at 0, right? And right, that will be at last index. That will be target dot length minus 1, correct? Now what's next? We will be having one while loop. As I said, we will be traversing till what? They will where is the point? Towards each other, beginning. Basically we will check the condition till they cross each other, right? If they cross each other, that means our result is not there. We will return false. Okay, so we will be having one while loop. While left is smaller than right, correct? Then what else? Within this we will be having condition. Before that we will calculate the sum, right? That will be equal to target of left plus target of right. It's not target, it's number. Here also it's numbers. Okay, so of right, correct? Now we got the sum. We will check if this sum is smaller or greater than the target, right? So if sum is equal to target, we will simply return the indices, right? That is, we will return, let's say, int result, right? And here we will return, or we can store in array list, right? And then we can add the result, that is the left plus 1, right? And array dot add right plus 1. After that we can make a new array. And we can add this, right, of to length res 0 will be arr dot at 0, 1 can be arr dot res. right? After that we will check else condition, right? Else if sum is smaller than the target, then what we will do, we will increment the left pointer, right? Otherwise we will increment the right pointer, and at the end we can return false, or let's make it here only. Okay, let's try it. Left and right numbers. Why it's out of bound? Right, minus minus, sorry, minor mistake. Okay, it's accepted now, right? Here I am using the array list, right? You can simply add it here also, like this. Rest 0 will be what? This left plus 1, right? And here it will be RIGST plus 1. And why I'm doing plus 1? Because it's one indexed array, right? Let's try this. It's accepted. Okay, so this is the question. Now let's see the second question. Second question is remove the duplicates from the sorted array, right? So basically we are given one integer array, that is nums, sorted in non descending order, removing the duplicates in place. Now what is in place? In place means we need to modify the given array. We should not use the extra space or extra array, right? So such that each unique number or element appears only once. Okay, the relative order of the element should be kept the same, right? And then return the number of the unique elements in nums. Okay, so let's see the example directly. Okay, so this is the input given, that is nums 1, 1 and 2, and the output should be the number of unique elements, that is 2, right? 2 will be our output, and what else? Nums, that is 1, 2, and this element can be anything, right? So basically we need to, what we need to do, we need to change this one to unique element, that is 2, next unique element, right? If we see some another example, let's say this one. Okay, so basically we are having this array, right? This is the input, and we need to return the number of unique elements from this. This is the first output, output number 1, that is the unique elements, okay, and output number 2 is the array. Now array is not the extra array, this is the same array, right? In the question if you see, we need to use the in place, right? Remove the duplicates in place. In place means we need to use the same array, right? So I hope you understood this. In place meaning, so we need to edit this array itself, and we need to keep the unique elements at the first. This is the simple question, right? So if you see the output, let's write the first input, okay, 3, 3 and 4, right? What are the unique elements in this? It's 0, 1, 2, 3 and 4, right? These are the unique elements, right? Now the number of count is 5. The first output is 5, correct? The second output is we need to edit this array so that these unique elements should come in the first, right? We can do like, we will find the first, we will find these elements, and store it in some array. Then we will edit this, right? And we will keep the first elements as the unique, right? This is the first approach, but in this it will take the extra space, right? We should not use extra space. How can we do this? Now the output is first 0 will be there, right? This is the unique number. Now what is the next unique number? It's not 0, right? It's 1, correct? So 1 will come here, right? How can we do this? We will be using 2 pointers, right? 2 pointers will be there, and we will be basically, let's say first pointer is at this point, the second is at this point, right? Now it will compare both. They are same. We will move this pointer, right? It will come here, correct? Now it will compare both. It's not same. That means this is the unique element, right? So we will put this element in a result. That means what is the result? Result is the same element, same array, right? We need to edit this, correct? So we will update this element as 1, correct? Okay, so we got the next unique element. Now at this point j will come to this point, right? J pointer, that is the this one, and I will go to the next. I will come to this. It will compare with j. It's same, right? This is not unique, correct? Then it will go to 1, then again it will go to 2, right? So 2 is the unique element. It's not same, so we will add 2, right? And so on. It will now 2 will come. Now j will come here, right? Now it will compare with 2. It's not, it's same. It will compare with 3. It's not same. This is the unique. We will add 3 here, correct? And same with 4. We will add 4 here, and next element can be anything, correct? So let's write the code, and we will do the dry run also. Okay, so as I said, we will be having 2 pointers. First is I, first is j, second is j, right? Before this, let's check the length of this array. Now first pointer is at 1, right? And we will be using one for loop. This for loop is the second pointer. I is the second pointer, right? Initially it will be at 1, and we will be running this for loop while I is less than n and I plus plus, right? And in this, what we will be checking? We will be checking if they are duplicate or not, right? So nums of I with which? With the first pointer, right? I is the second pointer and j is the first pointer. So it should not be equal to nums j minus 1, right? Why minus 1? Because we should check the previous element, right? Let's say in this example we are running from, that is 0 0 1 so on, right? We are having both I and j here, right? I and j here. So we will be checking I with the previous element, that is j minus 1, right? Okay, so we will be checking with j minus 1, and then what? If they are not equal, that means they are unique, right? So we will update the element. We will do nums j equal to nums I, right? And after that j plus plus. Okay, let's see this. Let's see this. We are having 0 0 1 1, right? We are having both pointers at this point, I and j, right? So this is the unique. First element will be unique, right? This is the unique, we know. Now it will check for the previous element. It's same, right? We are doing what? If they are not same, then we are checking the condition. If it's same, it will directly go to the next pointer, right? I plus plus. So I plus plus, then it will go to what? It will go to this pointer, right? Now I is at 1, right? Now it will check again. It will check with the j minus 1. It will check array of j, right, should not be equal to what? Sorry, j minus 1 should not be equal to what? Array of I. It's satisfying the condition. Yes. At this point, this is 0 and this is 1, right? This is 0 and this is 1. At this point, what we will do? We will update this element, right? We will update this element. What we will do? We will do array j equal to array of I, right? Why we are doing this? Because we need first element as unique. So at this point, 1 will come, right? After 0, 1 will come, right? And we are incrementing j plus plus, right? Now j will come to here. That means before this, each element is unique, right? We are having 0 and 1, they are unique. And so on, we will get 2 and 3 and 4, right? Okay. Okay. So now you are understanding. Okay. So that's it. This is the case, right? If we see further, then we will be having 0 0 1 1. After that 2 was there, right? After that 1, then 2 2. Okay. 1, then 2, then 2, right? Correct. And then 3 3 and so on, right? Now we got the 0 and 1, correct? Now 0 and 1, and j is now at this point, right? And I will go to here. It's same, it will compare, right? Then when it will come to 2 I, right, it will compare with this element, right? With this element, it's same. No, it's not same. Then what it will do? It will check the condition, it satisfy, then it will update the element, that is array of j, right? Which means this element, it will update it as 2, right? So we will get 0 1 and 2, right? And I will increment, I will go to here. Sorry, j will increment, j will go to here, right? And like this we will get 3 here. Now 3 will come to here and 4. After that, whatever element is there doesn't matter, right? It will be 2 2 3 3, doesn't matter. It will check only first unique elements that we are returning, right? Negative number, for negative number also it will compare, right? It will check if it's same or not. Let's say here it's not 1, it's minus 1, then also it will simply check the condition if it's same or not, right? If it's not same, then it will add it minus 1, that's it. For let's say this is 3, let's say we have minus 3, so it will add minus 3, that's it, right? And we are having two outputs, right? This is the second. What about first? See, j will come at the end, j will be here, right? J will be here, right? What is the j? J is the count of unique elements. If we use C, j is the count of unique elements, right? These elements are unique. So for the first output, we can simply return j. Return j, right? So that's it. If we run this, okay, it's accepted now. Now the next question, validate palindrome. Now you know what is palindrome. Let's see the question. A phrase is a palindrome if, after converting all uppercase letters into lowercase and removing all non-alpha numeric characters, it reads the same forward and backward, right? Let's see the example. If we are having one example, let's say, madam, is this a palindrome or not? This is the palindrome. We can read madam from the front as well as from the back, right? Basically this character is equal to this one is equal to this, and middle is the common, right? So madam, for the palindrome we will check the characters from the beginning till the mid element, right? We will check if this, let's say we are using 2 pointers, right? Let's say this is I and this is J. We will compare them. I is equal to J, yes, as equal. Then we will move further. I, next pointer, that is at A, and J to this direction, that is A. Again it will compare A, these are equal. Again it will move and it will come to the I equal to J. We will stop. We will say yes, this is the palindrome. Okay. Now let's see another example. Let's say A, B, C, D, A. Okay. Now we will be having 2 pointers, one at the beginning, one at the end. We are using 2 pointers, right? So it will compare. Both are same, right? We will move to the next element, right? Now these are equal or not? These are not equal. We can simply return false. Okay, false. We can say this is not the palindrome because the elements are not equal, right? Simple question. Let's move to the question. Now this is the tricky part, right? We are having a string. In that we will be having one space also, this comma also, right? So we need to remove them, right? And we need to convert all uppercase letters into the lowercase letters, right? So the first work is uppercase to lowercase, right? This is the first step. Now what is the second? If you see the question, the second is remove all non-alphanumeric characters. How you can remove? You can use the regex here. Okay, remove all non-alpha. Okay, you will use regex here. For this you will be having the string function. I will tell you which one. To lowercase, right? To lowercase. It will convert all the characters to lowercase, right? And regex, for regex there will be having we will be having different expressions. Using that we will be converting our string. I will show you. Okay, the third step is we need to check same forward and backward palindrome logic, right? Okay, so first I already told you we will be using to lowercase, right? So this is the first. Second, now second is tricky. We will be using regex. Let's say we are having this input, right? So in this we are having spaces, right? Spaces are there, comma are there, right? We need to remove this and we will get this input. Okay, so how can we remove? We will use regex function. Which function? See, we will be using s dot, s will be the string, right? This is the string. We will use replace all, right? And now we will write the regex expression. Let me write, then I will explain you. A to Z 0 to 9, right? Replace to what? To empty string, right? So what we are doing here? So basically this is the expression, right? This is the expression, the regex expression. Now it's saying we will be having all characters from A to Z and all numeric values from 0 to 9, but we are having this operator also, right? This is the not operator. That means if other than these elements are there, we should replace them with empty string, right? Let's say we are having the space, right? Space is there. This is not the character between A to Z or a number, right? So we will remove this with what? We will replace this with empty string. What about this comma? It will check if it's between A to Z. No, it's not. If it's between 0 to 9, it's not. we will replace it with empty string, right? So at the end, what we will get, we will be converting to lowercase, right? We will get a space man comma a plan, right? We will get all characters in the lowercase. Now we are removing extra spaces, this commas and everything other than this characters and the numeric values, right? So we will get a man a plan and so on without any comma or this space, right? So now this is the output we will get. Let's write it. A man p l a n a c a n a l p a n a m a, right? So this is the output we will get after these two operations, right? To lowercase and to replace all non-numeric and non-alpha characters, right? So we will get this output. Now we need to check if this is palindrome or not. Now we will be using 2 pointers. One pointer is at the beginning, the other at the end. We will compare a is equal to a. Yes, it's equal. We will move the pointers, this one towards the end and this one towards the beginning, right? It's same. Again we will increment this one and decrement this one, right? It's same. It will go to till middle, right? When left is smaller than right. While we satisfy this condition, till then it will run. If left is equal to right, that means the middle element. At this point we will return true, right? So let's write the code. So we need to convert to lowercase s dot s to lowercase, right? After that we will be applying regex place all. And what was the expression? First not will be there, right? After that a to z and 0 to 9, right? That means other than these characters we will be replacing with empty string, right? So we converted the uppercase to lowercase and remove all the elements other than the characters and the numbers. Now we need to check the palindrome, right? Let's have n, that is s dot length, right? Now we will be having for loop int I equal to 0, I less than n by 2, right? And I plus plus. We can also have the while loop here, okay, as we did in the first question, I guess. Yes, here, right? So now here we will be checking if s dot caret what I is not equal to s dot caret. Now we are not using j here, right? We will be using I only, but how? We will be removing I from the total length, right? Let's see. If this is at 0, then n minus 1 is the total length of this string, right? Means the last index will be I minus 1, right? N is the length. This is the last index. We will be doing what? I minus 1 minus I, right? If this is at 0, this will be at the last index. Let's say if this is at I equal to 3, right? 1 2 0 1 2 3 n, right? What will be the answer here? Total, let's say anything, it will be 1 2 3 0 1 2 3 n, right? 3 from the last, right? So we will be using this expression here, that is n minus 1 minus I, correct? We can also use j here. Okay, return false. If this is the case, return false. Okay. Okay, otherwise after this we can return true. Okay, let's run it. It's accepted. So what we are doing, we are basically checking the characters from the beginning and from the end till the middle point, till n by 2, right? So that's what we are doing. If at any point they are not same, means this is not the palindrome and we can return false, right? So we are using 2 pointers here, right? First at the beginning and second at the last. Correct. How do we know for which question we can apply 2 pointers? Okay, so this was the question, right? Here we need to calculate the pair of two numbers. Here comes pair of two numbers. We need to find two numbers. So in that case we will check if we can apply the 2 pointers or not, right? So in this case, right, we can see we need a sum from, like, this is the sorted array, right? And we need a sum equal to target, right? So we can think like using which two numbers or which condition we can get this target, right? So we can decrement the numbers from the last and we can increment the number from the beginning, the index, right? So in that way we can think like where we need to find the pair of numbers, or a sub array we need to find. Let's say in this we need to remove the duplicates, right? We are basically checking the what, the number with the previous one, right? Here we are using 2 pointers. How? See, we are at this point first and we are checking the next pointer, means we are comparing two numbers, right? So in that case also we can use 2 pointers, right? If you see, we are comparing one with the next one and the next one. Basically we are comparing two numbers, correct? So we can say if we are going to through the array and we are comparing two numbers, in that case first we will see if we can apply 2 pointers or not. In some questions there can be scenarios in which 2 pointers can't be applicable, right? So we need to check if this is applicable or not, right? Okay, so the next question, the common question. Okay, the container with most water. Okay, so we need to find basically the container which can have the most water, right? Let's say you are given an integer array, height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height I. Okay, what is this? This is basically, see, let's copy this. Okay, so we are having this graph. Now we need to find the container. What we need to return, let's copy this also, the area, I think, right? Okay, so we are given the input, the array of the heights, right? The first height is 1, so 1 bar is there. The second is 8, so length of 8 bar is there, right? And so on. And we need to calculate the maximum area, that is 7 into 1. This is 1, this is 2, 3, 4, 5, 6, 7. So 7 into 7, right? 7 is the base and 7 is the height, right? So it's 49. So we need to return the area of that part, right, which can contain the most water. How can we do this? See, one thing you can see, this is the greatest height from the left side, right? And this is the greatest height from the right side. You can say this is also there, but if we calculate the area of this, for this it's 1, 2, 3, 4, 5. 5 is the base and height is 8, right? So here it's 40 only, right? It's not the greatest area. So we need to find the greatest area, right? So two things we need to check. First is the greater height, right? Greater height from left and right. The second is this, the maximum area. Okay, maximum area. We will only update the area if it's greater than the previous one, right? Sorted array. Yes, this is not the sorted. This is not sorted. Here, see, first thing we need to find greater height from left as well as from the right. Correct? So we will be having 2 pointers. That is one for the left, one for the right. Correct? So one for the left, one for the right. Because these bars only can make an area, right? Make an container, we can say. So okay, so we will start from where? We will start from first pointer from the left and second from the right. Correct? Then we will check what? We will calculate the area using the heights. How? Let me show you. So the area, first pointer will be here, right? And second will be here. Now what is the area for these lengths? For these lengths, it should be minimum of both, right? We can't hold the water like this, right? We can't hold the water like this, it will overflow, right? We can only store the water till the minimum length, right? It can store the water till here. Correct? This is for the area when left is at first index and right is at last. Correct? So we got the area. What is the area? 1 into first area is 1 into the height of this bar is the base of this is what? 1 2 3 4 5 6 7 8. 1 into 8, that is 8, right? First area is this one. Now we will do what? We need to increment or decrement our pointer, right? We need to move either left or right. Correct? Now which we will move? This is the question. How can we find? Basically we will move if the smaller one, right? We will move this left. This is the smaller. We will compare both the heights. We need a maximum area. So for the maximum area we should need a maximum, the larger bar, right? So we will move this pointer for larger bar because this is the shorter, right? If we compare left and the right, the left is 1, the right is 8. For the maximum area we should need a maximum bar, right? So we will move this. Now left will come to this point. Correct? Now what is the area at this point? It's 7 is the base, right? 7 is the base. And what will be the height? See, it can't store the water till this height, right? It will flow from here, right? It will flow. We will be having water till this point, till the minimum bar of both left and right, right? So it can store the water here. Correct? So what is the height? Second area is 7 is the base and height is what? Height is 7, right? We got 49. Correct? Question is simple. We need to find the container with the most water and we need to return the maximum area, right? I'm explaining the question only, right? So what's next? We will calculate the next area. Now which pointer we will move? We will move the smaller height pointer, right? In this case, let me raise it. Left was at here and right at here, right? Now it will compare. Left is 9 now, 8 and it was 7, right? Which one is smaller? Right is smaller. So we will move this. We will move. It will come to here, right? Right is here. Again it will compare the area. What is the height? Minimum height from both left and right. It's 3. So 3 into bases 1 2 3 4 5 6 into what, height is 3, 18 only, right? Again it will move, this is the smaller height, right? It will come to here, now it's equal, right? So what is the area here? The base is 5 and the height is 8, it's 40. Till now the greatest area is 49 only, so we will not update our result, right? It will be 49 till now. Now both our heights are equal. What we will do here, we can either move left or right, it's our choice. Okay, so let's move left. It will come to here, right? Again it will calculate what is the base, 1 2 3 4 is the base, and what is the height, the minimum height, right? It can store the height, it can store the water to the minimum height, correct? What is the height? It's 6, so it's 24 and so on. So the maximum area we will got 49, we will return 49, right? So I hope you understood how we are using 2 pointers here. Basically we are calculating the area, right? We are calculating the area using left and right pointer, and then what is this happening? And then what we are doing, we are moving our pointer. Which pointer? The pointer which is having the lesser height. Why? Because we need to get the maximum area, right? So first thing is we need a greater height from both left and right, right? Right, it will tell us which pointer we need to move, right? And we will calculate the area using that pointers. What is the base case here? Base case will be like the first case will be our base case, right? So we are calculating the area. Initially what we are doing, we are calculating the area. It will, in first case it will be having 8, right? So if we will not get any area greater than this, the 8 will be our answer, right? Okay, I hope you understood what we are doing. We are first calculating the area using both pointers. Then what is the next step? Next step is moving the pointer with less height, right? We are moving the pointer with less height to get next area, right? Then third point is comparing the area, store the larger area, the largest area. Okay, at the end we will return this largest area. That's it. Okay, so these 3 steps we are performing here. So let's write the code. We will be having one left pointer that is at 0 index, right? The second, the right will be at the last index. What is the last index? That is the length of this height, right? Height dot length -1, correct? After that we will be having one variable that is max area, in which we will be storing our max area. Initially it will be 0. Now till what point we will be running? Okay, this base case you were asking. Okay, base case will be middle point. Okay, till middle point, let's see, till here we will be running. Why? Because after that it can't store the water, right? If both pointers will be at same bar, how can they store the water, correct? So we will be having this condition till left is smaller to the right. Where is the mouse? Okay, while left is smaller than the right, till then we will be calculating the current area for each step, right? So it will be what? see, we are doing what? We are having this, right, the left bar and the right bar, correct? We will get the minimum of both, right? Minimum of left and the right. Let me show you. While we are calculating this area, right, the initial one, what is the height we are taking? We are taking the lesser height, correct? Because water will flow above this point, right? So we will be taking the minimum of both left and the right height. So math dot min, what? Height of left and of right, correct? After this we will be multiplying it by with base, right? For area we need to multiply length and the breadth, right? So multiply with what? With base, that is what? Right minus left, right? After that we will be having the max area. Okay, max area will be what? Math dot max. It will compare with this current area and the initial max area, right? Area and the current area, right? So whichever is larger, it will store in the max area, right? So if you see the example, the initial one was 8, right? So max area till this point was 8, right? Then 49 came. It will check if the current, this was the current, right? If the current area and the max area, whichever is larger, max area will be that, right? It will be 49, right? So we are storing the max area into max area variable. After that, what? Now we will be moving our pointers, right? So for that we will be checking the heights. Height of left, if it's smaller than height of right, what we need to move? We need to move left variable, right? Whichever is smaller, we will move that. Else we will move right. Now right we will do minus minus, right? We need to move towards beginning. After that, at the end we will return max area, right? Let's run this. It's accepted. So I hope you got the logic, right? So here what we are doing, we are running this while loop till when left is smaller than the right, right? And for each step we are calculating the current area, right? For current area, sorry, we are having the minimum of left and the right height, correct? As we see, we will be using the lesser height and we are multiplying with the base, that is left, that is right minus left, correct? Right is larger. After that we are comparing with the max area, right? Whichever is larger, it will store in the max area. After that we need to move our pointers, right, for the left and the right, and we will move whichever is having the lesser height to get the maximum area, correct? For this we can see we will be moving our left pointer, right? Initially our pointer was at this point left, right, and right was at this point. Now it will compare whichever is smaller, it will move that. At this point we will move the left, right? So that's what we are doing here. We are comparing the heights and moving the pointers. At the end we will be returning our max area. Let's submit it. It's accepted. 8th line, please. 8th line. Okay, so we are using basically the minimum height, right? So if you see, initially we are having left pointer at here and right at here, right? So for the area, which height we will use, left or right? For the, if we are seeing the right, we will be having the area like this, right? But the water will flow right from here, so we will be using the lesser height. That means this area can be there. So this is the area. So what is the height? We are using the minimum of both left and right. What we have written here, right? Minimum of left and right, correct? Then we are multiplying with base, right? For the area we will be having one height and one base, correct? Or we can say length and breadth. So what is the length here? It will be 1 2 3 4 5 6 7 8 8. That means right minus left. Right is 9 and left is 1. We got 8, right? So simple area formula we are applying here, and we got our area. Then we are checking the max of both. These are the questions with the platform link. Okay, 15 questions are there, so you can solve this.